So what we're going to do here is balance oxidation-reduction reactions in acidic media in this video. And the first thing is I have a handout that I gave out to the students. So step number one is to write the species that participate in the reaction as we see it. Then we have to assign oxidation numbers to the various species. So each one of these, I did that for oxygen, it's -2, unless it happened to be a peroxide, then it'd be -1. For hydrogen, it's +1 unless it's a hydride, so that's -1 if that was the case. And the other ones that are here, like the carbon and the chromium and this carbon here, were determined by just using an algebra-like problem where you can, let's say for carbon here, we assign this as x, and as the unknown, set it equal to whatever the overall charge would be on the compound, or if it was an ion, like this guy here for dichromate, it would be -2. Step 3 is to figure out the half reactions. We've got to figure out what's being oxidized and what's being reduced. Well, we see that chromium is going from +6 to +3. Well, if that's the case, if you're losing the value, if it's actually going down, it's a reduction. And carbon, we see, is increasing in oxidation state, so that's oxidation. So we'll use those for our half reactions and then fill everything else in. You need to add waters, H pluses, and a few other things. So for oxidation, we have C2H5OH goes to C2H4O2. Reduction, we have Cr2O72 minus goes to Cr3 plus. Okay, step 4 rather, to balance all elements except hydrogen and oxygen. So I'm going to use this chalk right here to do that. The carbons are already set, so we're safe. With the chromiums, there's 2 chromiums here. There's only 1 here, so we'll put a 2 there. Step 4, part B, balance oxygen by adding the appropriate number of water molecules. Well, we count up the number of oxygens. We see we have 2 over here, and there's only 1 here. So we add 1, we'll use blue here, water molecule on this side. Well, we have 7 oxygens here, nothing over here, so we add 7 waters on that side. So that takes care of the oxygens. Part C of step 4, balance hydrogen by adding the appropriate number of H plus ions. So I'm going to use yellow chalk for that. We count the number of hydrogens on both sides. Well, we see there's 2, there's 5, that's 7. We have 8, 4 only on that side. So we add 4 H plus ions there. Down here we see we have nothing on this side. We have 14 here. So we're going to add 14 H plus on that side. Okay. Next is to balance the charges by adding the appropriate number of electrons as either products for the oxidation portion or reactant side for reduction. Just remember reactant side reduction. All right, well, let's see how much we have. Well, what I mean by that is let's see what the overall charge is on each of these compounds or ions, where we have 0 and 0. There's a 0 here, +4. This we have +14. -2, 2 times 3 is +6, and we have 0. So we have to have both sides equal each other. It doesn't have to be 0 on both sides, but it has to be equal. Well, we see we have 0 here, we have +4 here. By adding the electrons, we actually will reduce down that side. So we're going to add 4 electrons here. So now both sides are going to be equal. This side here, well, we have +6 over here, and here we have +12. So we want to bring this down to +6, so we add 6 electrons, and both sides are now equal. Again, it doesn't have to be 0, just equal. Next, step 5 is multiply either both or both half reactions or one of them, depending, to equal out the total number of electrons that are transferred. Well, we have 4 here, 6 over here. So what we're going to do going to have to multiply both these reactions by some whole number. We'll multiply this one by 3 and that one by 2 to get 12 electrons on both sides. Now, next step is to add both these half reactions. And when we do that, we have to make sure we multiply through as needed. We do all the reactant side first, and then we will do the product side over here. So we have 3 waters, 3 C2H5OH, plus we have 2 times 6, that's 12 electrons, 2 times 14, that's 28 H plus. We have 2 dichromates. On the other side, we have 3 C2H4O2, and we have 12 H plus and 12 electrons. Down below, we have 4 Cr3 plus and 14 H2O. Now, the last step is to simplify and rewrite the equation once we're done with that. So let's see what we can do here. Well, we have 3 waters on this side, 14 over here. So we'll get rid of the waters here and make that we have 11 waters over on this side. Down here, that stays there. We don't do anything with that. We have 12 electrons here. We'll get rid of that. We have 28 H pluses. We have 12 over here. So I'll make this to 16, and of course everything else stays as is. So C2H5OH plus 16H plus 2 Cr2O7 2 minus gives us 3 C2H4O2 plus 4 Cr3 plus 11 waters. And if we did everything correctly, of course, we should have everything balanced out nicely. And one other thing to look at is that charge is conserved, so we want to make sure that the total overall charge on both sides will be equal. Again, it doesn't have to be 0. Well, this is 0. We got plus 16 minus 4 overall, so that gives us plus 12. We have 0 plus 12, 0, so overall plus 12. Charge is all conserved.